Hey everybody again, and here we are for the solution to the question from the last video. And just for your information and mine, the last video was 9 minutes and 21 seconds, so that's how I'm keeping track of them. So we left off with the challenge of a certain question that says if V2, the final velocity of V2 was 1.6 meters per second, 30 degrees south of east, what would be the angle that the shooting rock or the shooter would go? Okay, so we're going to quickly go through this, and first thing I want to do is I drew a diagram, and if you draw a diagram, you can't go wrong. So here we are. We have the shooting rock. So right, this is the mass 2 that's on its way here. So that's mass 2. It's going at 16. The momentum is 16 Newton seconds. Remember, that's our unit that we've used in class, and that is a vector. And so there it is, right there, 16. That came from 10 kilograms times 1.6 meters per second. 30-degree angle, and I want to break this into its component parts. I chose 30 degrees because it's a nice one to do mental math with. So I'm going to take P2 Fy. That's a lot of subscripts, but it's the momentum of rock 2 final in the y direction. So this purple line that you see here, it's going down, and let's just not worry about that just at the second, but this purple line, P2Fy over, I should call this one here P2F, P2Fy over P2F is the sine of 30. The sine of 30 is 0.5. So P2Fy, without messing up the whole page, is going to be 8. I'm just going to put it here. There, well, yeah. There it is, 8. So we have 8 kilogram meters per second here. We have 16 kilogram meters per second here, and whatever we want to do to get this red one, this x component here, you can do. You can use Pythagoras, you can do trigonometry, whatever, but it has a value. Let's see, what did I say that value was? 30 degrees. I wrote it down on one of my notes here. 13.8. 13.8. I'll just explain. I went 16 squared minus 8 squared, and I'm going to take the square root of that. Yeah, 13.8. Sorry about the pause there. 13.8. Okay, that's great. So now we're going to take what we know about this one, and we're going to create the shooter rock, and I'll do that right down here. And we use our conservation of momentum rules as well. I'll just slightly do this. Okay, so here comes the shooter. It's right there. That's mass 1. Now, 13.8. Remember the red dotted lines we had in the last one? Well, I'm going to put that in again. We know that this red plus this red have to equal 20. So I'm just going to do that. What number does it take to make 20? If you start with this one, and obviously it's 6.2. And remember, all the momentum in the up and down direction had to equal 0. So this was 8. And I'm going to make this another 8. technically speaking, this is -8. Hopefully that's well, here, I'll do this. There we go. And that, of course, is a right angle. And what is our resultant? Our resultant is the path that this rock is going to take. This is obviously a little bit out of scale because that's 8, this is 6.2, but I'm just acknowledging that. So what do we have here? And what is it we've been asked? We want to know what this final angle is. Okay, let's go over here. We'll simplify it a little bit. We'll go like this. 8, 6.2. And the angle, well, the angle that we're interested in is opposite over adjacent, and that suggests tan. Tan of the angle is equal to 8 over 6.2. Is that in my screen? Yep. Which is also equal to, I forget what that number was. 8 divided by 6.2 is equal to 1.29. Take the tan inverse of 1.29, and you should get an angle that's more than 45. I know that much. 52.2 degrees. Okay, so there is your answer. And if we could take it a step further and say 52.2 degrees north of east, but when we see 52.2 degrees with no directions, we're assuming it's going in a circle such as this. It's going this way, measured that way. Okay, so have a great day, and I shall see you soon, I hope.